Okay, so question number 1 says, describe how Moseley and Mendeleev arranged the periodic table. Dmitri Mendeleev, how did he arrange the periodic table? Jules? How did Dmitri Mendeleev arrange the periodic table? By? Excellent, by increasing atomic mass. And then Henry Moseley rearranged by increasing what? Good, by increasing atomic number. Which one do we use today? The atomic number. So make sure you know that. Excellent. So on the periodic table below, label and color each family. Give the number of valence electrons and the ion charge. Anytime you're given a periodic table or a blank periodic table, make sure you write the energy levels and go ahead and write 1A, 2A, 3A, 4A, all the way to 8A on your periodic table. Okay, so that A tells me what? The number of valence electrons. So I have +1 charge, a +2 charge, a +3. Carbon group is a plus or minus 4, depending on where it falls within the zigzag line. -3, -2, -1. And then, of course, the noble gases have 0 charge. Remember our Hill method if you get lost. 1A, 2A, 3A, 4A, going down the hill, 5A, 6A, and 7A. So +1, +2, +3, plus or minus 4, -3, -2, and -1. Okay, any questions on that? All right, so the first group is called the what? Good, alkali metal family. It's the most reactive family. Then we have the alkali earth metals. Remember, this is what was in the crazy water, and that crazy water tasted what? Salty. And so that's why they're called salts, is because they form salts. The next group, group 7A, are called the halogens. Then last but not least, the noble gases. Okay? This big block, which we're going to learn next week, is called the D block. What is this group? The transition metals. And the ones at the bottom, these are called what? The inner transition metals. Okay? Any questions over that? All right, on the periodic table below, color the metals, nonmetals, and metalloids, and draw and label each trend. So your periodic table basically should look similar to this. Always start by drawing your zigzag line. Okay, and again, we're going to write the energy levels. Go ahead and get always in the habit of doing that. That way we have reference points. So everything to the left of the zigzag line are metals. Everything to the right of the zigzag line are nonmetals. And what borders the zigzag line? Okay, so everything that borders the zigzag line are called what? Metalloids, with the one exception of aluminum. Good. Are all metals solids at room temperature? No, what's the one exception? Mercury. Excellent. All right, so ionization energy trends. Let's look at that. What is ionization energy? The energy required to... Good. You can break that word down. The word ion, to gain or lose an electron. The suffixation, the process, or to become. So the energy required to become an electron. So helium has the highest ionization energy. So this is the trend. Okay? Electronegativity. Electronegativity, the ability to attract an electron. Why do noble gases have zero electronegativity? Right, they're stable. They don't want to attract an electron. Excellent. And then atomic radius. Francium has the highest atomic radius, so the trend is opposite. Okay? All right, flipping over to the back. What does the number next to the A represent in each family? Good, the valence electrons. And we go 1 to 8. Which particle is responsible for the charge of the ion? The electron. What families of elements are the most reactive metals? Alkali metals. And for nonmetals, it is the halogens. Good. What makes noble gases different from other families? They have zero charge because the full valence electrons. Okay. What is the name of the horizontal row on the periodic table? Show me with your arms the horizontal. Good. And so we end a sentence with a period. What is the name of the vertical column on the periodic table? Good. A family or a group. And remember, a period can also be called an energy level. In a group, the number of blank is the same for every element because of this, all the elements in that family have the same number. What is it? The number of valence electrons. Because they have similar properties. Nonmetals form ions with a negative charge because they gain or lose. They gain electrons, while metals form an ion with a positive charge, and they lose electrons. Which particle is most important in determining physical and chemical properties? The electrons. Ionization energy is the energy required to remove an electron. Electronegativity is the tendency of an element to attract electrons when they are chemically combined with another. And atomic radius is the size of the atom. For the next group, you have to have a periodic table. Circle the element that has the smallest ionization energy. What element has the largest ionization energy? Helium. So whatever's going to be furthest from helium. So sulfur, neon, and aluminum. Here's helium, sulfur, neon, and aluminum. In this case, it asks for the smallest, so it's going to be opposite. But I like the way you're thinking. Great job. So aluminum, sulfur, and neon. So here, aluminum will have the smallest. And then strontium, phosphorus, or oxygen. Strontium, phosphorus, or oxygen. So strontium will have the smaller. For the following groups of an atom, circle which has the largest radius. So which element has the largest radius? Francium has the largest. Let's see, is the largest. What, baby? Okay, not talking to me. Lithium, cesium, or oxygen. Which one has the largest atomic radius? Cesium. What, baby? The one closest, exactly. It was the one furthest away for ionization energy because it asked me for the smallest. Neon, arsenic, or krypton? I'm sorry, nitrogen, arsenic, or krypton? Nitrogen, arsenic, or krypton? Which one is closest to francium? Arsenic. So it will be arsenic. Rubidium or rubidium plus 1? Rubidium, because rubidium plus 1 loses an electron. Arsenic minus 3 or arsenic? Minus 3, right. Circle the element that has the greatest electronegativity. Fluorine has the greatest electronegativity. So, potassium, selenium, or lead? Potassium, selenium, or lead. So we're looking for something close to fluorine. Potassium, selenium, or lead. Which one would it be? Selenium. Excellent. Oxygen, boron, or gallium? Oxygen, boron, or gallium? Oxygen. What if I asked you neon, gallium, or indium? Which one would it be? Gallium, because remember, noble gases have 0 electronegativity. An atomic number increases by going down the grid. What also increases? Okay, so the mass and anything else? Energy levels. What happens to the radius when an atom becomes a negative ion? So as we go across, what happens to the atomic radius? It decreases. Atomic structure review. Guys, this is so important. There's a bunch of questions over atomic structure on this next test. The number 56 in iron 56 represents the isotope mass. Yes, it's isotope atomic or mass number. Given the symbol 8035 bromine, how many protons does the atom have? 35. And how many neutrons? 80 minus 35 equals 45. A sample of an element contains 92.21% of type 1, which is 28 AMU, and 7.79% of type 2, which is 30 AMU. Calculate the average atomic mass. So 92.21% times 28, and then 7.79% times 30 AMU equals. Remember, we have to move that decimal 2 places. So this will be 0.07. And we do the math. So 0.9221 times 28 is what? 25.82. And then is 2.34. And we add them together and we get 28.16 AMU.